Okie dokie. So we're trying to find a point on this line here that is equidistant, so it's the same distance from A as it is from B at some point on this axis here. And if we're talking about a point that's equidistant from two other points, we're talking perpendicular bisector here. So every point that's equidistant from A and B, so every point that's the same distance from A as it is from B, is going to be on that perpendicular bisector. And that perpendicular bisector is going to cut through here, perpendicular to the segment AB, and it cuts segment AB in half, perpendicular, and bisector cuts in half. And it's going to pass through the axis somewhere up here. And we just got to figure out where. So, let's see. First, we'll just have to write the equation of this perpendicular bisector. So we're going to have to find the midpoint here. So let's take a look. Midpoint of AB is, well, it's going to be 0 plus 8 over 2 and 0 plus 5 over 2, which is really 4 and 5 halves. 1, 2, 3, 4, and up here. 4 and 5 halves. Now to write the equation of the line, we need the slope of AB, which is easy because it's just 8 over 5. So it's over 8. I'm sorry, 5 over 8 over 5 over 8 up. Oh, it's too early in the morning. Over 8 up 5. So a rise of 5, a run of 8 is 5 over 8. So the slope of the perpendicular bisector will be the negative reciprocal of 5/8, or negative 8 over 5. So now we can write our equation using y equals mx minus h plus k, where m is the slope of the line and hk is a point that the line passes through. And the slope we know, negative 8/5, and the point is 4, 5 over 2. So y equals negative 8/5 x minus 4 plus 5 halves. So you know, we've got to do a little, see, negative 8/5 x, see, 4 times 8 ABC 5 is 6 2/5. 32/5, that's going to be positive because these are negative, plus 5 halves, negative 8/5 x, plus this number plus 5, ABC 2, 8 9/10, or 89/10. Now, to find out, in the past we've had to go ahead and to find some point of intersection, to take the other equation for the other line and set these two expressions equal to each other, etc., etc. But here we don't actually have to do that because we're simply asking when does that line cross the y-axis. Well, it's the y-intercept, which when we're in y equals mx plus b form is right there. It's 89/10, or 8 9/10. So our point of intersection is 0, 89/10. Let's just check, see if that kind of makes sense. Our slope was negative 8/5, so we're going to go up 1, 2, 3, 4, 5, 6, 7, 8, and over 1, 2, 3, 4, 5. So we're going to pass through that point there. Draw our line in. I'm just going to draw the line in. This isn't going to be, of course, super precise because we're not even graphing from lattice point to lattice point, but I just want to see if that looks like it's approximately 8.9. 1, 2, 3, 4, 5, 6, 7, 8, and almost 9. So I think that seems reasonable. Our rough graph backs up our calculation, so it seems like we're on the right track. So there we go. So again, the process was we knew that the point we were trying to find was going to be on the perpendicular bisector. So we find the equation for the perpendicular bisector. First, we have to find the midpoint. Then we determine the slope. Then we use point-slope form in order to write the equation. And then using the equation to find the point of intersection, which in this case was a little less work than usual because we're just looking at what's the y-intercept of that line. There you go.